In this demo, we will show how to connect a serial device to a Rockwell ControlLogix or CompactLogix PLC. To do this, we will use the EtherNetIP to serial linking device from HMS Industrial Networks. The linking device works as a translator between an EtherNetIP-based Rockwell PLC and serial devices, enabling them to communicate. In this example, we're using a ControlLogix 1756L71 as a PLC and a Rockwell Powerflex 4 drive, which is set to use Modbus RTU serial communication. The PLC and the linking device are both connected to the Ethernet IP network. The entire implementation of the Powerflex drive is fully integrated into the Rockwell Studio 5000 Logix Designer environment, and I can set up the communication between the PLC, the linking device, and the drive from here. So I open Studio 5000, and under I/O configuration, I right-click on Ethernet and select New Module. Here I can type in the module I'm looking for, or I can select the vendor, HMS Industrial Networks in this case. I can see that Studio 5000 has found the Ethernet to serial linking device. So I select this, click Create, and name it Serial Link. I assign an IP address for my linking device, which I've previously set up in the bootp software. In this case, the IP address is 10.10.55.120. I now click Change and get to a screen where I can launch the configuration manager for the linking device. So I'm now in the configuration manager for the HMS linking device, which is integrated into Studio 5000. The configurations are built as Modbus commands using queries and responses according to the Modbus protocol. Here I will create a new configuration with one register going in and one register going out from the Powerflex drive. I start by renaming my new node Powerflex 4. I can see that the slave address for the Powerflex is 1. This is the correct choice for my slave, so I'll keep this as it is. We're now going to add two Modbus commands, one for reading the drive's status word and one for writing the drive's control word. I right-click on my Powerflex 4 and select Add Command. A read input register first, and then a write single register. We now have a read and a write command to the drive. I rename the read register to status data and the write register to command data. Now I will enter how I want the data to be transferred. As we can see, the structure is built according to the Modbus standard. By referring to the Powerflex 4 manual, I can see the different values that I am to enter. The first value is starting address, which according to the manual has the hexadecimal value 2100. The quantity for input registers is 1. On the response side, the byte count and the input register data length is set to 2, since one register equals 2 bytes. The data location we keep at 0. This is because the input area of the linking device starts at 0. Okay, so that was the status data. I now move on to the control word, where I do the same thing with my manual at hand. The register address is 2000. Under register value, the data location is set to 200 since the output area starts at 200. Note that this is a hexadecimal value. It is also possible to type in a numeric value. The software will automatically convert it to a hexadecimal. Moving on to the response. The register address is 2000. In the register value, data length is set to 2. The data location I put 400. This is because in single write command the response is not important, so we'll keep it in the internal memory of the linking device, which starts at the hexadecimal value 400. That concludes the configuration of the Powerflex 4 drive. I can go to Subnetwork if I want to change any of the communication or timing settings for the serial network, but in this case we'll leave this unchanged. We also have some general settings for the linking device under HMS EN to SER. I now want to add my Studio 5000 process tags. To do this, I right-click on Subnetwork and choose Process Tag Editor. Here I can see two Modbus commands each with a size of 2 bytes. I simply click Tools and Generate Process Tags, and the named and structured process tags are automatically created. Powerflex 4 Status Data 1 and Powerflex 4 Command Data 1. The naming of the process tags is generated from the tree structure we just set up, and these will later be automatically transferred to the Studio 5000 project. The last digit is simply there to make the names unique. Since there are no other commands with this naming structure, I can remove this. I can see that the start address is 0 for data going in. I can see the bit number, which is 0. This parameter is only valid if the data type is set to Boolean. The data type is an integer in this case, since it's a Modbus register command. In the dimension column, I can also make an array structure of this tag. In this case, we'll keep it at 0. OK, so I'm now done with this part of the configuration and can go to File and Exit. Just to show you a more complex configuration, I will open a file which I made previously for the Powerflex 4. I click File and choose the configuration called TSC Demo. Here we can see that I've added more commands such as error codes, frequency feedback, and speed reference. We have also generated tags for these new commands. I now click the Connect button and Download to download my configuration to the serial network. If I wish, I can monitor the data being exchanged between the Rockwell PLC and the Powerflex 4. To do this, I open the Node Monitor. There is also a data logger, which I can use to see which queries and responses have been sent and received between the PLC and the drive. So I now click File and Exit and click OK to apply these changes, and close the remaining windows. I'm now back in my Studio 5000 start screen. If I go into the controller tags and expand the serial link which I've just created, I can see that new controller tags are available in Studio 5000. The tags are ready to be used inside the PLC program. For example, I open my main routine and add a move instruction. Inside the instruction, I move the value of 100 to the speed reference tag that are linked to the Powerflex 4. So as you can see, the EtherNetIP serial linking device is a fast and powerful tool for establishing communication between a serial device and a Rockwell PLC.